You're going to need your property sheet if you haven't gotten that out. We're going to be filling in the rest of our properties today. We're going to talk about our special parallelograms from last time, and then we're going to learn our last three shapes, the isosceles trapezoid, the trapezoid, and the kite today. And again, the thing that worries me the most is how quickly we're taking this test, that you have to have your properties memorized. So make sure that you are studying that property sheet. Once you know your properties, the math is not as difficult, okay? All right, this section is kind of like what 6.3 was. If you guys remember, 6.2 we learned the 5 properties of a parallelogram, and then in 6.3 we looked at ways to prove that it was a parallelogram. So it's kind of like the converses, but we didn't call them converses. This is the same kind of idea. We learned our properties last class period about the rectangle, the rhombus, and the square. And then in this section, they're going to say, okay, is it enough to say it's a rectangle? Is it enough to say it's a rhombus? Is it enough to say it's a square? So just like before, some of these are going to be identical. Some of these you are going to have some shortcuts on how you can prove that it's a rectangle, a rhombus, or a square. But for all three of them, I have to emphasize, the very first thing you have to prove is that they are a parallelogram. They have to be a parallelogram before they can be a rectangle, a rhombus, or a square. Okay, so first they have to be a parallelogram, and then we're going to decide, do we have enough information to say it's something more. So on your property sheet, you may want to make another section for ways to prove it is a rectangle. And Javi, I sent out on Remind, did you get the pictures of the board? Okay, wanted to make sure, since I didn't really write that in the video. So ways to prove rectangle. So first thing you have to do, prove it's a parallelogram. And we have 6 ways from the last class period to prove it's a parallelogram. Once you have ruled in that it is a parallelogram, you're going to decide, is it anything more? Is it a rectangle? Is it a rhombus? Or is it a square? So once you prove it's a parallelogram, the second thing you're going to do is prove it is a rectangle. And I'm going to list below the ways you can prove it is a rectangle. But I want to make sure that you understand you first have to prove that it is a parallelogram. Okay, so one thing we learned about rectangles is that they have congruent diagonals. So one way to prove it's a rectangle, if it's a parallelogram, is if it has congruent diagonals. And I skipped to that second one because it is identical to what we learned last class. So that helps. The second way to prove it is a rectangle is a little bit of a shortcut compared to what we learned last class. So what we learned last class period is if it's a rectangle, it's going to have how many right angles? 4 right angles. Well, this says all you need is one angle to be a right angle in order to say it's in order to say it's a rectangle. And here's why. Let's write it down first. If it has one right angle, that's enough to say it's a rectangle. Here's why, though. Get a different color marker. So if I know for sure that I have a parallelogram, that means the opposite sides are parallel, right? And if I have one right angle, we learned in chapter 3 that if I have parallel lines cut by a transversal, then if this angle is 90 degrees, what does this angle have to be? 90, because they're going to be supplementary, right? And the same going this direction. Since these two lines are parallel, if this is 90, then this one's going to have to be 90. Again, because they are same side interior angles, and so they have to be supplementary. And then the same goes here. If this is 90, then this one has to be 90. So you only need one because of the rules of the parallelogram with those sides being parallel. But that's why you first have to prove it's a parallelogram with one right angle. Okay? You only need one of these ways to prove it's a rectangle once you have that it's a parallelogram. Any questions on how to prove it's a rectangle? Okay, again, I'm going to do the same thing I did last time. I'm going to skip ahead to ways to prove it's a rhombus, and then ways to prove it's a square, and then we'll look at some examples. So on your notes, ways to prove rhombus. First thing you're going to have to do, prove it's a parallelogram. I can't say that enough. You have to make sure it's a parallelogram before you can prove it's a rhombus. Second thing you'll do is prove it's a rhombus by one of the methods below. And I'll start with the ones that are exactly the same as last class period. So one of the things that was exactly the same is we learned that the diagonals of a rhombus are perpendicular. So if it has perpendicular diagonals and it's a parallelogram, it is a rhombus. Perpendicular diagonals. Okay, the next two ways are kind of shortcuts to what we learned last class period. So last class period we learned that if it was a rhombus, then all four sides of the rhombus would be what? Congruent. So this is going to say that you only need one pair of consecutive sides to be congruent. One pair of consecutive congruent sides. One pair of consecutive congruent sides. So you don't need all four to be congruent, you just need one pair of consecutive ones. Again, I'll explain to you why that is. So this is a little bit of a shortcut. You first have to prove it's a parallelogram, right? So if it's a parallelogram, what do we know about the opposite sides of a parallelogram? They're congruent. So if I have a pair of consecutive sides marked congruent, and I know that because it's a parallelogram, the opposite sides are also congruent, then that turns out to make all four sides congruent. So you only need one pair consecutive to be congruent. If it's a parallelogram, that will make it a rhombus. And then the last way to prove it's a rhombus, again, this is a little bit of a shortcut. We learned last class period that the diagonals will bisect opposite angles, but you only need one pair of opposite angles bisected to prove that it is a rhombus. So if you look at the picture, only one diagonal is shown and those opposite angles are bisected. That's enough to say it's a rhombus without drawing in the other diagonal and showing that the other pair are also bisected. So the last way to prove it's a rhombus is if you have one pair of opposite angles are bisected. One pair of opposite angles are bisected. And again, I can explain to you why that is. So I'm going to use this picture up here on the board, if you can see that okay. If these angles are bisected, and we already know that the opposite angles in a parallelogram are congruent, right? So in a rhombus, when that bisects those, it makes all four of those angles congruent. What does that make this triangle right here then, if these angles are congruent? Isosceles. So that means that these sides are congruent, correct? And same thing over here, this other triangle. If these angles are congruent, it makes it isosceles, so those sides are congruent as well, right? And they share this side in the middle, so it's congruent to itself. So by angle, side, angle, these two triangles are going to be congruent to each other, which means all four sides turn out to be congruent. And so that gives us a rhombus if all four sides are congruent. And then yes, all of the corresponding parts will now be congruent. But are you with me that by angle, side, angle, these two triangles will be congruent? Okay. And if these two sides are congruent and these two sides are congruent, then all four sides are congruent, which makes it a rhombus. Okay. So two shortcuts, a little bit different than what we learned last class, but still the same property. Just you don't need as much information to get there. For both of these, you have to prove that it is first a parallelogram. Okay, the square is the easiest. Ways to prove it's a square. Remember we said that a square is a parallelogram, but it is also a what? A rhombus and a Rectangle. So the way you prove it's a square is you prove that it is all three. You first prove that it's a parallelogram. And then you prove that it is both a rhombus and a rectangle. And it doesn't matter what order. So you're going to prove it's a parallelogram and then prove it's a rhombus or a rectangle and then prove it is the other one. And if it is all three, then it is a square. There's not any extra properties. The great thing about the square is if you know the properties of the rhombus and the properties of the rectangle, you know the properties of the square. So there's not any extra things you have to know. Any questions? Okay, let's look at some examples. Gonna go back to the ones I skipped. Except I hit the button too many times. Have a problem with that? Okay, first one we skipped right here. So a manufacturer builds a mold for a desktop so that AB is congruent to CD, BC is congruent to DA, and ABC is 90 degrees. Why must this be a rectangle? In order to prove it's a rectangle, you're first going to have to explain to me why it's a parallelogram, and then prove that it is a rectangle by one of these two methods. So let's start with the things they gave us, and let's mark our picture. AB is congruent to CD, and BC is congruent to DA. And then they tell us ABC is a right angle, 90 degrees, and they've already marked it. So based off that information, how do we know it's a parallelogram? Okay, so then on your paper, you could write down first, it's a parallelogram because of the property opposite sides are congruent. And then once it's a parallelogram, we either have to have congruent diagonals or we have to have one right angle. Exactly. So then we can say number 2, it is a rectangle because we have one right angle. So you just have to be able to back it up with a property that proves that it is that shape. And again, I point out, to make sure it's a rectangle, you first have to prove it's a parallelogram. Okay? That's all you have to do. Not yet. All right, so determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. And then they give us a lot of information, and their conclusion is this is a square. I skipped all the other little slides to get to this example. Are we good? Okay, because it's basically just our properties we listed over there. Okay, so let's start breaking it apart. In order to prove it's a square, what do we first have to prove? Parallelogram. So let's start marking some things and see if we end up with enough information to say it's a parallelogram. So EB is congruent to BG, and FB is congruent to BH. Start right there. If the diagonals bisect each other, is that enough to say it's a parallelogram? Yes. Okay, that's one of our, remember there's 6 ways to prove it's a parallelogram. And diagonals bisecting each other was one of those ways. So the first thing we could say is, and I'm going to go ahead and list this, it is a parallelogram because the property that diagonals bisect each other. Again, another reason you really need to know your properties because you'll have to use them to explain. Okay, so that was the first 2 pieces of information they gave us. Now if it's a parallelogram, what do we also have to prove it's a square? A rhombus and a rectangle. Okay, so let's go to some more information here. EG, this whole diagonal, is congruent to FH, the whole diagonal. Okay. Okay, careful. This didn't say they were perpendicular. This said they were congruent. So which shape has congruent diagonals? The rectangle. And also remember, if you forget which one's which, draw in the diagonals and look at the picture. It's very obvious they're congruent in a rectangle and not as obvious if you slant your rhombus because they look like one's longer than the other. So it's the rectangle that has congruent diagonals. So number 2, we can say it's a rectangle because it has congruent diagonals. So the last thing we need to say if their conclusion was valid or invalid is, did they have enough information to prove it was a rhombus? And the last thing they tell us is that these two triangles are congruent. So triangle EBF, which would be this triangle right here, and EBH are congruent. If those two triangles are congruent, do we have enough information to prove it's a rhombus by one of our ways for a rhombus? What would be the one way? Okay, if the two triangles are congruent, then that means EF would be congruent to EH, right? Yeah. And that means that we have one pair of congruent consecutive sides. So number 3, it is a rhombus. I would be okay if you just say one pair of consecutive congruent sides, but if you want to take better notes for yourself, if you're looking back over this later, you could say CPCTC tells us EF is congruent to EH, because that's how we knew that, right? If the two triangles were congruent, then their corresponding parts were congruent. And then we could say we have one pair of congruent consecutive sides. So is the conclusion valid or invalid? Valid. It is a square because it is everything else. And that's what it asked you. Determine if it's valid. If it's not, what additional information would be needed? So if you get to one on the homework and it's one where there's additional information needed, you may have to say, you need to prove it's a rectangle. Maybe we weren't able to prove it was a rectangle, or you need to prove it's a rhombus. Or you could get even more specific and say, you need congruent diagonals, or you need one right angle or something to prove that it is that shape. Any questions? Okay. All right, that was it for 6-5. 6-6 is where we learn all the rest and a lot of information in 6-6. I know, but I hope you're finding it isn't hard stuff in this chapter, right? It's just very important information that you too much to memorize, right? You got a lot to memorize here. Okay, so 6-6 is going to be, like I said, our last 3 shapes. We're going to have kites and trapezoids, and then we're going to have the special group of trapezoids called the isosceles trapezoids. Before we end today, make sure that I do a Venn diagram for you to help you organize all your different shapes. A Venn diagram, yes. So make sure I do that. Okay, so first I'm going to do like I was doing before. We're going to list all the properties of the shapes, and then we'll go back and look at the examples, okay? So we're going to start with our kite, and these are the properties of a kite. So we're just learning about the kite. First thing for the definition of a kite is it is a quadrilateral. It is not a parallelogram. So last class period we changed every one of those definitions to it is a parallelogram. Kites are not parallelograms. So it is just a quadrilateral, and it's going to have 2 pairs of congruent consecutive sides. So the first property for a kite is its definition. And that definition says it has 2 pairs of congruent consecutive sides. So not the ones across from each other, but the ones that are connected to each other. 2 pairs of congruent consecutive sides. Just like when you think of a traditional kite you fly in the air, that's what your kite looks like. Okay? Some more properties for your kite. The next property is that it also has perpendicular diagonals. So that's why you first have to make sure, is it a parallelogram or is it not a parallelogram? If it's a parallelogram with perpendicular diagonals, what shape is it? A rhombus. If it's not a parallelogram and it has perpendicular diagonals, it's a kite. So the second way to prove that it is a kite is if it has perpendicular diagonals. But again, you have to rule in or rule out the parallelogram first, so you'll know which shape has the perpendicular diagonals. Next thing about the kite is it has exactly one pair of opposite angles that are congruent. And I will show you which pair. So if you look up here at the picture, it is not the pair that is in between the congruent sides. So it is not A and C that are congruent. It's the pair of angles that are in between the non-congruent sides. So D and B. So when we list this here, I would probably list which pair we're talking about. So it has one pair of opposite angles congruent. And then you need to somehow list that it is the angles in between the non-congruent sides. Or draw yourself a picture maybe, so you can go back and understand this. It's these angles. Okay? The ones that are in between the non-congruent sides. One pair of opposite angles congruent. All right, I'm going to skip this example again and come back to it. And this one. Skipping a lot of examples. We'll come back to them. Let's get to the properties of the trapezoid. Okay? Trapezoid. All right, definition, and there's also some more vocabulary here for your vocab test, which don't forget again is tomorrow. A trapezoid is a quadrilateral. Again, it is not a parallelogram. It is just a quadrilateral, but it has exactly one pair of parallel sides. So the first property of the trapezoid is its definition. And it has one pair of opposite sides parallel. If it has two pairs, it's going to be a parallelogram. If it has only one pair, it's going to be a trapezoid. And then some vocabulary for you. The parallel sides, we call, those are the bases. So when we talk about a trapezoid, your trapezoid is going to have one pair of opposite sides parallel, and those sides are called the bases. So if you look at the picture, you'll see the parallel sides are called the bases. The non-parallel sides are called the legs. So the other two sides are going to be the legs. And then on your bases each form two of the four angles. The two that are made by the same base are called the base angles. So B and C would be considered a pair of base angles, and then A and D would be considered a pair of base angles. Okay, they are, but they're not all base angles together. So B and A are not considered base angles because they're not formed by the same base. So when we talk about the base angles, they're the two consecutive angles that have a common side as a base. Does that make sense? So C and D are not considered base angles together. Base angles have to be a pair, and they're the angles that share the same base. So B and C, and then A and D. Because that's going to lead us to some properties about them in a minute. Okay, that is the only property that we're going to write down here, but I do want to point out something about every trapezoid. If it has a pair of parallel sides, then what do we know about this leg if we think about it as a transversal? What's going to be true about angles A and B? They're going to be supplementary. What about angles C and D? Supplementary. okay? Not necessarily B and C, because these are not parallel, and not A and D. So it's going to actually have, every trapezoid will actually have two pairs of consecutive angles that are supplementary. You can write that down if you want to. It's not usually listed as a property of trapezoids. It's because of the fact that we have those parallel lines cut by a transversal. So we just kind of go back to that knowledge when we look at pictures. Is everybody with me there, though? Okay. So now we're going to move on to the isosceles trapezoid. This is our last shape. And it is a trapezoid. So the very first thing that's going to be true about it is it's going to have the same property as a trapezoid. It's going to have one pair of opposite sides parallel. So I'm going to put here, same property as a trapezoid. It's only one property up there, so same property. One pair of opposite sides are parallel. And then it's going to have its definition. Its definition is going to say that it is a trapezoid, but it also gives you more information. The definition for isosceles is, it is a trapezoid where the legs are congruent. So it's a trapezoid that has congruent legs. So by definition, it has congruent legs. And then again, I would remind yourself, you can draw a picture if you want to. The bases are the parallel sides. The legs are the non-parallel sides. So it's going to have congruent legs. So it's going to have one pair of sides parallel because it's a trapezoid. And then by definition, it'll have congruent legs. And then it has some more properties. Am I going too fast? Okay. All right, if it is an isosceles trapezoid, then each pair of base angles will be congruent. So it's going to have congruent base angles. Again, be careful, that's not every pair of consecutive angles. That's the ones that share the same base. So B and C will be congruent, and A and D will be congruent. Okay, so it'll have congruent base angles. So number 3, congruent base angles. It's going to have two pairs of those. I should have probably put that, so I'll write it here in parentheses. Two pairs. Two pairs of congruent base angles. Keep in mind the other consecutive angles are the ones that are same side interior, so they're the ones that are going to be supplementary. So A and B will be supplementary, C and D will be supplementary. All right, this is basically the same thing. It's just saying you can prove that it is a trapezoid that it's isosceles if it has only one pair of congruent base angles. So you know how every section we've had, like we learned about parallelograms, and then we had a section that said this is how you prove it's parallelogram. Then we learned about rectangles, rhombuses, and squares, and then we had a section that proves it. They just put all of this in one because the ways to prove it's a kite are the same as the properties, and the ways to prove it's a trapezoid is the same as the properties. The isosceles trapezoid has one shortcut, and it's this one right here. So it's going to have two pairs of congruent base angles, but you can add right here, you only need one pair to prove it. So they don't do a separate section of how do I prove it's a trapezoid, how do I prove it's a kite, because there's not anything different except in the isosceles trapezoid there is one shortcut. And you only need one pair of congruent base angles to prove that it's an isosceles trapezoid. And here's why. If this angle's 30 and this angle's 30, if it's a trapezoid, then that means what is angle B going to have to be? 150. And what is angle C going to have to be? 150. And so now you're automatically going to end up with two pairs of congruent base angles. So you only need one pair to prove it's an isosceles trapezoid. But once again, you're going to first have to prove it's a trapezoid before you can prove it's isosceles. Okay? And then the last property of the isosceles trapezoid is it also has congruent diagonals. Which shape over on that side of the board has congruent diagonals? The rectangle. So just because it has congruent diagonals doesn't prove it's either shape. You have to either rule in that it's a parallelogram or rule out that it's a parallelogram and rule in that it's a trapezoid. If it's a trapezoid with congruent diagonals, then it's an isosceles trapezoid. And this is where it starts to get a little tricky because some of these shapes share the same properties. So if you'll just remember, before you can prove that it's any of these, you have to prove it's a parallelogram. And then before you can prove it's an isosceles trapezoid, you have to prove it's a trapezoid, which rules out that it's a parallelogram. Okay? That's the hard part. All right. So before you can prove any of these shapes, you're first going to have to decide, is it a parallelogram or is it not a parallelogram? Because we learned the parallelograms are on this side of the board and the non-parallelograms are on this side of the board. So you're going to rule in, yes, it has one of our 6 ways to prove it's a parallelogram. And then if it does, you can either rule in that it's a rectangle now or a rhombus or maybe all 3 and it's a square. If it's not a parallelogram, it only has one pair of opposite sides parallel or no pairs of opposite sides parallel. Then you're going to decide, is it a kite or is it a trapezoid? And if you can say it's a trapezoid, you're going to go a step further to check and see, could it be isosceles? Okay, so the big kicker is it a family of the parallelogram or is it not a family of the parallelogram? And it could be none of these. It could just be a quadrilateral that has nothing special about it at all. 4 sides, no parallel sides, no congruent sides, just a 4-sided shape. Okay, let's look at some problems, but before we do, I want to make a Venn diagram so I don't forget. So let's do that as well. Kind of helps you when you get to the always, sometimes never questions on the test. The Venn diagram could be really helpful for that. No, but you can study it and draw it yourself. Okay. I'm actually going to skip this first one because it's the hardest, and we'll do the easy ones first, and then we'll come back to this one on the last. Okay, so before we do that, let's draw our Venn diagram. So I'm going to have to make it kind of small because my boards are both covered up over here, and I don't want to erase anything, so I can take pictures of this and send it to both Edwin and Elena, since they're not able to see the boards today. Yes. So here we have a Venn diagram. So on your paper somewhere, draw yourself a great big giant rectangle or circle. Okay. And inside this shape, we're going to be talking about all the quadrilaterals because that's what this chapter has been about. So all the quadrilaterals. So inside my big circle or rectangle are quadrilaterals. Okay, in the quadrilaterals, we have 2 categories. We either have the ones that are parallelograms or the ones that are not parallelograms. So I'm going to draw a pretty large circle here for my parallelograms. And then inside the parallelograms, what 3 shapes are parallelograms? Rectangle, rhombus, and square. One of those 3 is always both of the other ones. Which one is both of the other 2? The square. So when we draw the rectangle rhombus circles, we want them to overlap because where they overlap, what the properties or the shapes that have both sets of properties are going to be called the squares. So inside this little overlapping section, I'm going to have the square. And then one of those circles will be the rectangles and one of them will be the rhombuses. Does that make sense? Okay, and then if it's not a parallelogram, we have 3 options. It could be a kite, could be a trapezoid, or more specifically an isosceles trapezoid. The kite is all by itself. It has no parallel sides whatsoever, right? So we're just going to have somewhere over here that's not a part of the parallelograms. These are our little kites. They're all alone, separate by themselves. If you are a kite, you are not a parallelogram. If you're a parallelogram, you are not a kite. But if you are parallelograms or kites, you are quadrilaterals. Is that making sense? Okay, and then we have our special group that is going to be a little bit bigger because inside this is all trapezoids. But if you're a trapezoid, you could be more specifically an isosceles trapezoid. So it's all inside here. And this is the isosceles trapezoids. But once again, if you're a kite, you are not a trapezoid and you are not an isosceles trapezoid. So they are not connected or touching at all. If you're a trapezoid, you are not a parallelogram. If you're a parallelogram, you are not a trapezoid. Does that make sense? So if I asked you questions like rhombus, a rhombus is always, sometimes, or never a parallelogram. A rhombus is always a parallelogram. If my pencil is in the rhombus circle, it is always inside the parallelogram circle. How about a rectangle is always, sometimes, or never a rhombus? They overlap, right? If my pencil's here, it's not a rhombus. But if my pencil's here, it is both a rectangle and a rhombus, which makes it a square. So if I'm a rectangle, could I be a rhombus? But am I always a rhombus? No, so that would be sometimes. So that's how you can use your Venn diagram in your mind is can my pencil be inside that shape and be inside the other shape? If so, then it would be sometimes. If it's always inside that shape, then the word answers always. So again, a kite is always, sometimes, or never. I got you. A kite is always, sometimes, or never a quadrilateral. Always. A quadrilateral is always, sometimes, or never a kite. Sometimes, because I could be in the kite circle, but I don't have to be. Does that make sense? Okay, so you're going to have questions like that, always, sometimes, never, on your test, and it will be related to the Venn diagrams. Of course, just wait till I pass the test out, then you can draw anything you want on your test as soon as I do. Yes, you're always welcome to do that. That's why I pass out the graph paper, though, so that I don't have students who take a piece of graph paper and write stuff on the back of it before the test and then make it look like they have this blank piece when they really don't. But as soon as I give you a piece, you can write anything down you want. Okay, let's practice some problems like you'll see them on the homework. So first thing they tell us is this is definitely a kite, which means we know these properties. They want us to find the measure of angle BCD. BCD. So we're looking for this whole angle right here. They tell us that DAB, yes, angle DAB, this angle is 54 degrees. And they tell us that angle CDF, this angle right here, is 52 degrees. And our goal is to figure out the red angle. So tell me what you're saying. Okay, so be real careful saying perpendicular bisectors. It is perpendicular, but it's just perpendicular diagonals, right? Okay, so we do know the diagonals are perpendicular, which means we do know that these are all right angles right here. Okay, so one way we could work the problem is to say we could look at this little triangle here and say if this is 90 and this is 52, then this part of this angle has to be whatever adds to those to get 180. Or the quicker way might be to say if this one's 90, these two have to add to be 90. So what is 90 minus 52? 38. And if this is 38 degrees, how does that help me find this whole angle? Okay, and how do we know it bisects it? Because that's not one of our properties. But that's not one of our properties. It doesn't say that the perpendicular diagonals bisect the angles. That's not true for kites, not for every angle. Okay, but that's for parallelograms, and a kite is not a parallelogram. So that's why I'm asking you, What Tyler is saying is true, but only for angle C and angle A. It would not work for angles B and D because we do not have a property that says the diagonals bisect opposite angles on a kite. So let's think about our... Okay, so another way to work the problem, but I'm going to come back to what you guys have said because I want to make sure we're all clear here about the kite because it's tricky. Another way you could work it is to say, if it's a kite, what do we know about BC and DC? They're congruent. So then that means this triangle right here is isosceles, right? Which means if this is 52 degrees, then this angle over here is 52 degrees. And then we could say that in the great big triangle, 52 plus 52 is how much? 104. So 180 minus 104 is how much? 76 degrees, which is what we're looking for, right? Which would be 38 times 2. But every angle in a kite is not bisected. Only one pair of opposite angles. And it's the pair that are not congruent. So remember in your kite, you have one pair of angles that are congruent. The other pair get bisected. And the reason they get bisected is because, think about this triangles again. We have this side's congruent to this side. We have that they're both right triangles, right? And then using reflexive property, we have that this CF is congruent to itself here, right? And that gives us hypotenuse leg to prove that these two triangles will be congruent. Are you with me there? We've got the hypotenuse marked congruent to the hypotenuse, and a leg is shared by reflexive, and they're right triangles because of the diagonals being perpendicular. So if these two triangles are congruent, then that means that this angle here has to be the same as this angle here. Yes, hypotenuse leg. Are we good with that explanation? That's also going to be true then down here on the bottom two triangles. Do you guys see there? We've got right triangles. It's a kite, so that means this side's congruent to this side. And they share this side in the middle with reflexive. So again, you'll have hypotenuse, leg, so these two triangles will be congruent, which is going to make this 54 split in half. But this little green triangle is not congruent to this little blue triangle. Okay, so that means this angle D is not necessarily split in half. This green and this blue are not congruent, so that means that that angle B is not split in half. So what you need to remember is that you'll have two sets of congruent triangles in your kite. One pair of opposite angles are going to be congruent. It's the other pair that ends up being bisected. And if you want to write that down, you can. You can also go ahead and draw in those diagonals to make sure you're clear that these two triangles are congruent. So you have two triangles congruent up here, and then you have two triangles congruent down here. But you do not have two here and two here. Those are not congruent triangles. Okay, so that makes this angle congruent to this angle and this angle congruent to this angle. But these are not split into two congruent parts. As far as like notes to yourself, you could write down that you have one pair of opposite angles congruent and the other pair, the other pair is bisected. If it's not something that they'll ask you about as far as a property, because it's not necessarily one they list as a property, but it is what you would have to think about in order to solve the problem. Okay? Javi, yes, it will always be that way because these two triangles are going to be congruent, and because of that, that angle is always going to be bisected. I'm not going to ask you to do that. Yes. Okay. I don't think I have anything that's that difficult. You could, but I don't. Yes. Yes, what you did is totally fine. And what Javi did was fine. Either way would work. Okay. Any questions before we go on? Okay, same picture, same problem, but this time they want angle ABC. Did I mess it up? Let's see. A, B, yep, it's not letting me write. Sorry, go ahead and see if you can figure it out. Let me shut this down and start it back up because I messed it up. Okay, so this time we're looking for ABC. This angle here. We already know that this one's 52. These are all 90. This was 38. This was 38. We already found out this was 52, and we knew this was 54. Is that right?
Yep.
Okay, so what can we do?
Well, you already know your 52. You know you got 90 degrees and 54.
Careful, 90 and 54 added together.
Well, split the 54 in half.
Okay, so if we split this in half, what does that make this angle right here and this angle right here? Okay, 27 and 27. So you're right, we can do 90 from 27 or 90 plus 27 from 180. We can find this other missing piece. So what is 90 minus 27 or 180 minus 117? Either way you want to look at it. 63 degrees. So if this is 63 degrees, what does that make that whole angle ABC? Add them together, so it is 115 degrees. And then again, we can see that that angle is not bisected, right? Any questions about that? Okay. All right, the next one, same picture, but this time they want FDA. We already pretty much talked about it. We just found out these were all 90. This was 52. This was 38, 38. 52, we found out this was now 63. These were each 27. So what is that missing FDA? 63, because we talked about how there are going to be two sets of congruent triangles, right? So it's going to have the exact same measure as this angle right here. So 63 degrees. Any questions? All right, so trapezoid, we already talked about all the vocabulary. Isosceles trapezoid, all the vocabulary. All right, so now we look at this picture. Once again, there's no name, it doesn't tell you what it is. When you get to the test, you're going to have to look at the markings and decide what shape do I have here. So based off of these arrows, that tells me what? Okay, so I have one pair of parallel sides. That rules in which shape? If it has one pair of parallel sides, what shape is it for sure? Trapezoid. Okay, the other sides are not marked parallel, so that does not make it a parallelogram. The other sides are marked congruent, so what does that tell us it is? Isosceles trapezoid. So then we can look at our properties for isosceles trapezoids. We're looking for the measure of angle A. What do we know about isosceles trapezoids? Okay, so first B and C will be supplementary. That has to do with the fact that we have one pair of parallel lines cut by a transversal. So if this is 100, what does angle B have to be? 80. And then Molly said in a isosceles trapezoid, we know that there are two sets of congruent base angles. So that means angle A is also 80 degrees. Questions on that one? Okay. All right, this one, what shape do we have based off the markings? Okay, again, isosceles trapezoid. This time they want us to find the length from F to B, which is just this little piece right here. They tell us that KB, this longer piece of the other diagonal is 21.9. And they tell us that M to F, which is the whole other diagonal, is 32.7. So what could we do there? Okay, so the first property that we're using is that the diagonals are congruent, right? So if it's isosceles, the diagonals are congruent, which means if this one's 32.7, so is this one. And if we do 32.7 minus 21.9, what does that give us? So 10.8. And that would be the other little piece that's right here, which would be congruent to the little piece FB that we're looking for, right? So that means FB would also be 10.8. It won't be hard as long as you know your properties. The properties are the hard part. Knowing when to use them and where. My goodness, they go so long proving everything. Okay, what shape do we have here? Just a trapezoid, right? One pair of parallel sides, no legs are marked congruent. It says find the value of A so that it would be an isosceles trapezoid. So what has to be true, excuse me, about these two consecutive base angles if it is an isosceles trapezoid? Okay, they need to be congruent. So they want us to find the value of A that would make them congruent, so we're going to set them equal to each other. A squared plus 27 should equal 2A squared minus 54. Going back to our algebra skills, what would we do? Add 54. So we have A squared plus 81 equals 2A squared. Subtract A squared. What is 2A squared minus A squared? Just 1A squared or just A squared. And then we take the square root. Careful, what is A going to equal? Careful. If I take the square root of both sides of any plus or minus 9. Anytime you have something squared and you're solving, you should get two solutions. A is both positive or negative 9. Go in, plug it in, and make sure that both would work. What's going to happen when I square positive 9? It's going to stay positive. What happens if I square the negative 9? It's going to stay positive. So that means in this case they both work. And if you only put positive 9, you would miss half the question because there's two solutions. So make sure you're careful. Okay, always check it. Sometimes the negative doesn't work. Sometimes the positive doesn't work. It just depends on the picture and what the expression is. Your angle has to be positive, not the variable. The variable can be either one. All right, this one, find the value of x so that ABCD is isosceles. We know for sure it's a trapezoid by the markings. AD is this diagonal, BC is this diagonal, so if it's isosceles, what should be true about the diagonals? They should be congruent. So again, you're just going to set them equal. 12x minus 11 should equal 9x minus 2, and solve for x. This one's easier. We can add 11. 12x equals 9x plus 9, and then subtract 9x. 3x equals 9, so if we divide by 3, what is x? 3. Only one solution because it's linear. Easy? Okay. The next thing you're going to see in your note is a connection back to triangles and something we learned with triangles. And that was mid-segment. So remember we talked about mid-segment theorem with triangles. A triangle could have how many different mid-segments? 3. And when you drew all 3 mid-segments in, you created what was called a mid-segment triangle. You guys remember that from chapter 5? The definition for a mid-segment on a triangle was a segment that connected any two midpoints of the sides of the triangle. In a trapezoid, the definition for midpoint is not the segment that connects any two midpoints. It is specifically the segment that connects the midpoints of the legs, and only the legs. So you're going to have one pair of sides that are parallel, which are your bases. The other sides are your legs, right? The mid segment is going to go from the midpoint to the midpoint on the legs. Okay? And there's only going to be one mid segment in a trapezoid. Are we good with that? What do you think will be true about the mid segment compared to the bases? Okay, it's going to be parallel. The mid segment will also be parallel to the bases, just like the mid segment was parallel to the third side in the triangle. Okay, in the triangle, the mid segment was parallel to the third side, and it was what compared to the third side? Half. So that's similar here, but not quite. The mid segment is not going to be half of this base, and it's not going to be half of this base, but it's going to be half the average, or the half of the sum of those bases. So if this were, let's say, 4, and this were 6, then this should be halfway between 4 and 6, which would be 5, because 4 plus 6 is 10, and if I take 10 and divide it by 2, I get 5. So it's going to be halfway between there. So it's going to be the average of your bases. Does that make sense? A triangle only had one base. A trapezoid has 2, so we're going to have to average them. So that's called your trapezoid midsegment theorem, and it's simply going to be very similar to your triangle midsegment theorem. The midsegment, there's only going to be one of them, will be parallel to each base, and it will be half the sum of the bases. That's the only difference. You've got to add the bases together and then take a half. Are we good with that? Okay, so the example they give you here, find EF. Should be pretty easy. What are we going to do? Add them up. 8 plus 13.5, and then take a half. What is 8 plus 13.5? 21.5. And what's half of 21.5? 10.75. That is EF without a line segment above it. Do not put a line segment above it. Is that right? Okay. No line segment because you're giving me distance. Okay. They'll make it a little bit harder on the homework. They might not tell you this is 8. They might tell you that this is 10.75, and they may call this X. If they did that, you would just simply say 10.75 should equal half of 13.5 plus X. Does that make sense? And then just work backwards using your algebra skills to solve for X. Because your mid-segment should equal half of the sum of the two bases. So they would have to give you 2 of the 3, but they may not give you the 2 bases. They may give you the mid-segment and 1 base. All right. The only thing left in your notes we didn't go over was the hardest example I skipped, right? So let's go back to the front real quick, and let's look at that one I skipped, and then we'll be done. And I say it's hard. It's not hard. It's just long. And sometimes the longer ones feel harder. But the process of the knowledge is not difficult. But you will have one like it on your homework, so I want to make sure that we talk about it. The homework is not a worksheet tonight, by the way. It is out of your book and core math book. Sorry. I know. It's nice to have a break from it, but I'm not going to do all of one way or the other because there's good things in both places. So some good worksheets, some good stuff in the book too. All right. So Lucy's framing a kite. So now we're back to the kites. Back over on this side of the board, no parallel sides. Lucy's going to frame a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters, 1 dowel that measures 30 centimeters, and 2 dowels that measure 27 centimeters. Okay, wrap your head around this whole problem. The dowels are like the little wooden rods that make the kite, okay? Keep it stable. So she's got 2 dowels that measure 18, so that's the frame here. She's got 1 dowel that measures 30, and notice it's going horizontally, so that's going to be the distance from what point to what point? J to M, so that's taking care of this dowel. And then she has 2 dowels that measure 27 centimeters, so that's going to be on the frame outside here and here. Are we good with that? Okay, so the only place she hasn't put a wooden rod is along KL, right? And that's going to finish framing up her kite. So to complete it, she needs a dowel placed along KL. She has a dowel that's 36 centimeters long, and she wants to know about how much wood will she have left after she cuts the length of KL. So we have to find the length from K to L. We're in a kite. What do we know about our diagonals in our kite? They're perpendicular. So we know all 4 of these are right triangles. And we know that JM is a total of 30, but we know that triangle 1 is congruent to triangle 2, right? Which means what has to be true about this piece and this piece? They got to be congruent. So what are they? 15. Does that make sense to everybody? Okay. And so then we need to figure out, I'm going to call this point in the middle that doesn't have a letter. I'm just going to call that, I'll call it B. I don't know. Just pick a letter. I'll call it B. So I need to know the distance from K to B, and I also need to know the distance from B to L so that I can add those together to get that whole distance. So it's just Pythagorean theorem. But how many times are you going to have to do Pythagorean theorem? Not really 4 times, just twice, right? Because I just need this piece, and it's the same in each triangle that it shares. Okay, so let's do the Pythagorean theorem real quick. And it says about how much wood. It didn't say didn't say to round, but it didn't say you couldn't round. And so on this one, we'll just go ahead and round at the end. So we have, what would be my first Pythagorean theorem? 15 squared plus b squared equals 18 squared. All right, 15 squared I know is 225 plus b squared. I don't remember what 18 squared is. 324. And then we're going to subtract 225 to get that b squared is equal to 99. And then we're going to take the square root of that. Let's simplify it first just to practice. So what is the square root of 99 without a calculator? Okay, so it should be 3 square roots of 11, right? If we had to leave it exact, we should be able to get 3 square roots of 11. Agreed? Okay, now let's go and do it again for the other triangle. So now we're looking at this bigger triangle. What's my Pythagorean theorem going to be? 15 squared plus b squared equals 27 squared. Again, I know 15 squared is 225 plus b squared. I don't have 27 squared memorized. 729. Subtract 225. So b squared is equal to 504. Take the square root. We could still simplify that too. That's going to take a little bit more work. 504 factors into what 2 numbers? You said 227 and 2, okay? And then 227. Will 3 go in there? Nope. 4. Okay, let's don't make this hard on ourselves. Let's don't worry about simplifying that. I don't know that it will go any further. So it did say about how much, so let's go ahead and add these together. So if we do the square root of 99 plus the square root of 504 is approximately how much? You can't add those and get 1 square root because they're not the same. Remember, to add radicals, they have to have the same radical. So if we just type in square root of 99 plus square root 504, what does that give us? I can grab mine too and check it with release. I'll switch over to this. So we have square root 99. Make sure that you close that parenthesis or end that arrow when you get to your calculator so that you don't keep the square root going, plus the square root of 504. My calculator is not updated. Yours will have a square root continuing to go. You're going to have to hit the right arrow key to stop that square root before you enter the next one. Oh, I don't know why I did that. How about this? Okay, so about 32.4. Okay, so about 32.4, and the question was, how much does she have left? So 32.4, and she had a 36 centimeter long piece. This is about 32.4. So 36 minus 32.4 leaves her with how much? 3.6 centimeters. So approximately 3.6 centimeters is how much Lucy has left over. So she can frame her kite and have a little bit of wood left. Any questions? Okay, that's the end of chapter 6, guys. You have everything you need. You already have the review. Here's the homework assignment. Again, when is this technically due? Wednesday, but if you don't give it to me until Wednesday, you don't get any feedback on it. So if at all possible, try to do it tonight. Turn it in tomorrow. I can grade it, and then Wednesday you can come look at it before your test. But it's not due till Wednesday, so worst case scenario, you turn it in Wednesday. All is good.